Okay, hello. Uh, I hope that I don't have a frog in my throat anymore. Uh, I did in the testing audio that I did for this. This is going to be a peculiar example of this series. I'm not sure what to call these yet. I guess I'll call this, like, I don't know. I'll figure it out in the uh, YouTube creation area. If this is your first time watching one of my videos, I'm sorry, I'm human, I make human noises. Uh, that's about the long and short of that. Now, this is going to be the first of two. I was going through and graphing the 3-star series, and something I really, really liked was... So that's the third chapter. Like, the chapters are... Oh, crud, I think I screwed that up. Let me just make sure I didn't. How elegant. I should have just done that. And because of my peculiarities, I must make sure that that's cut and cut correctly. Hold on. You gotta cheat. So what we're going to be looking at in this short video, compared to the longer, like, just videos where I'm just graphing as I go. I'm telling you, man, it's like I am fine right up until I have to talk. No breathing problems whatsoever, and then I get up to some recording, and then all of a sudden it's a problem. So anyway, so this is like chapter 3 right here, so you can think of the little numbers indicating what chapter the theorem's in. So, in case I haven't somehow explained that yet, I have to legally tell you not to use a Q-tip like I'm doing right now to help with your ear problems. Don't do that. If you do, and you tell people that I told you to, you're a liar. You cannot sue me over that. I explicitly told you not to. Anyway. So what we're looking at here is star 324. Now, I'll remind you that, so for instance, it goes 301, 302, 303, and then 31, 311, 12, 13, 14, and then 32, 321, 22, 24, 26. So there's some that are skipped. I could explain a different time why, but I want to keep this compact. I want this video to be about 324. And the dimplication, as I call it, you can pause the video and read here if you want to. But this is the dangling implication. The dangling implication substitution, as I call it. Yes, right here. The dangling implication substitution method seen in 216 and 217. Now this should be 217, I think. Yes, okay. I could have brought up 216, but I figured I'd stay with 217 because it's a little bit simpler. And you can see the difference where, like, back in this position in time when it was first earliest going, like my earliest ones of these were very space inefficient compared to over here, nice and, you know, nice and compact. I'm not going to explain exactly how this works because the point of me having it on the graph is that you can go and, you know, you can compare it to the graph to kind of get what's going on. So I'll go ahead and you can look at the screen if you want to. Just stop right here so that you can see how the demonstration was written for this one. So that's for what we're going to be looking at. And then here's 217. I didn't show how 217 was originally written back whenever I made this one. I probably should have included the as written, but whatever. Hopefully from this you can figure it out. I mean, I could write it down from how it's written here, but So what should be noted here is that it's P, it's not P and not P. That is 324. That's the law of contradiction, non-contradiction. It's basically the thing that says you cannot have both P and not P. So something cannot both be true, and so both it and its negation cannot be true in the same sense, essentially. Like, you cannot both be dry and wet in the same sense at the same time. That's just not, that's a contradiction. That just doesn't exist. Like, you can't be on fire and cold, right? Like, in the same, you can't be both on fire and not on fire. You can't be both underwater and not underwater in the same sense at the same time. Contradiction just doesn't work. Now, the demonstration is what I call a justification. I'm not really sure if that's how that works, like if that's what the proper terminology is. But as you can see here, this is how the demonstration was originally written. So it's star to 11, not P over P, and then the assertion, not P or not P, implies. Now, that's the dangling implication there. So these together, as written, like in the demonstration in the book, there is no little like one there after that. That's not a thing that exists. Oh, that's not a thing that exists in there. So just saying, it does actually look like that in the book. Now, that dangling implication then leads into, oddly, another callback. I'm not really sure what to call these, like references, justifications, whatever, but it calls back to that, to star 3.14, not P over Q, and then it goes into not P and not P and not P. So I think I should have gotten crud. I should have gotten that. I don't have it here, but you know what? I'll tell you what. I'll actually just go ahead and write that out. Okay? It's not that big of a deal. So we're going to skip. Just imagine that the little assertion sign is in front of this. It is not P or not Q implies not P and Q. Okay? So again, the thing we're missing there is a little assertion sign. The reason why I didn't do that is because that can be messed up by the like whenever I go to push A, because you have to hold down Alt and then numpad plus and then press 22A2, at least on my keyboard, my Unicode stuff. I don't know for you, but that's how I get that to come out. Whenever I hit A, it messes stuff up. So, I guess I could try to snag this if we want, the authentic. And I say a lot. Warning, I say because that's just a filler for me, other than and ah and stuff. So this is what it looks like right in the book. It's not P or not Q implies not P and Q. Now that's the thing, is that in dot notation, this is a conjunction, this is a separation on either side. This is an operator, this is the disjunction, implication, and then this is what your conjunction is. So it would actually look like if I were to use a modern conjunctive, okay? Now, if I were to go one step further, what dot notation is doing here, and I said I wouldn't explain it, but this is kind of important for comprehension for anyone watching this, but what the dot notation is doing here is basically making this I'm. It's such a habit to use dot notation that I just did it like automatically. I'm not sure if this is how it would look in modern necessarily, but oh, and I forgot obviously the. Thankfully, that's a really easy fix. Check this out. Isn't that beautiful? So that's all this actually means is not P or not Q implies not P and Q, right? So there you have the full translation. And this right here again is this is 314. With a gradated translation layer. Okay, so that's what this is. Just to keep this in memory, in loving memory. Oh, wow. Yeah, in loving memory indeed. I definitely killed that. There we go. We have un unflooded, unerased this. There we go. So just keep that in mind. That's what this is referring to whenever it says, whenever I use the substitution symbol, which is how I use that little symbol right there. That means that that's specifically a dangling implication substitution symbol. So that means in the notation for this, whenever you see that little guy, and it shrank, but I'll show you over here. This fella is the dangling. It's the dimplication, dangling implication substitution. So dimplication symbol. Now what that means is, right, if we take how this is written and what it's doing here, so let's copy and paste that over here so that we can kind of get an idea of what's going on. First, so that references 211, right? Why did I get 217 again? Oh, right. To show the dangling implication at work here. This references 205 for its, but let's look at 211. So that references 211. Obviously, I just repeated myself because I'm a bit dumb. Also, this is kind of the law of the excluded middle. That's a different thing, kind of. Maybe not really. I don't know. I'm just going to skip right over that. Point is that whenever it says 211, not P over P, what it's showing is that, right, you're going for, okay, this is a little bit difficult to describe too, because if you look over here, should be transposition, right? So P implies not Q, implies Q implies not P. That's one of them. Is it commutative? No. Oh man, I think it's this is going to be a little hard to express. It's kind of associative. No, is it associative? Permutative. That's it. And we need this anyway. So if you put together permutative and transposition, I promise this makes sense. So if you look at permutative, what's being shown here is that P or Q implies Q or P, meaning it doesn't matter which one is on which side. Just like how 1 plus 3 and 3 plus 1 is the same thing, right? Now, imagine you have, this one's a little bit harder to get at. Yeah, I'm gonna be crud at explaining this because this doesn't really oof. This is a lot harder for me to explain. But the gist is, if you put these two together, so P or not Q implies not Q or P kind of thing. Like that works with regardless, okay? So to get back at that, whenever it says 211, not P over P, and then you get not P or not P, right? You're replacing this where it's at with not P, and not P is just P, right? So essentially all you've really done is swap them from one to the other, okay? And that's what this is. So that's what this is not P or not P. You get that? So what's happening next is that this, not P or not P, is being shoved into star 3.14. Now that may seem a little like, okay, let's skip the not P over Q for a second. Right? So this is star 3.14. Just let's look at that for a minute. Over here, what's happening with 217? This is another dangling implication, right? This is getting fed in from 212, and I really should have gotten 205. Oh well, 205 is right here written, I guess. So let's put this up here and take a look at it. So this is not Q implies Q, and that's being put into a dangling implication, a dimplication. Dimplication star 205, and then down here, dimplication star 205 is what gives this new assertion it's basically what it is. Like it makes it what it is. Now, if you notice, this is P implies not Q, and P implies Q. Now, the thing that's happened here is, let me just make sure I got that right. Okay. So what's going on here is it not Q? I'm so sorry. I legit don't know why I keep having that problem. I'll try drinking some tea. Now look at the shape, right? You're going to look at this and go, wait, where did P come from? Why is this related to 205? What does the implication have to do with this? Well, if you look at the shape, right, this is P implies Q. Implies P implies R. What has happened is that the antecedent, I think I said that correctly, has been replaced 1-to-1. This is why it's a dangling implication substitution. Okay? Now the thing is that whenever we're talking about the antecedent, this is Q implies R, implies P implies Q implies P implies R. Now if you wanted to write that in like semi-modern, I guess, here's how that would look instead of in dot notation in parentheses. Alright? Check this out. So that would be I think I got that right. Yeah, okay. So that's what it would be in parentheses. So you can also here get an idea of like how dot notation works. Let's just go ahead and put that there, then cut it out. Let's cut that out. Cut out all the nonsense. So as you can see, right, this is the actual structure. Now, if we're going to mark the antecedent, you can think of it as a hinge, like a system of hinges, right? So this would be, I usually don't like red as a just instructive color. So you can think of that as one side of a hinge, right? And this is the other side of the main fulcrum, fulcrum, right? And that's the consequent, which makes sense, like the consequence. So Q implies R implies P implies Q implies P implies R. You get it? And that's kind of a big part of this whole, like what makes this work is that I'm showing visually the system of hinges, right? Now I'm not going to graph all of this out. You can get the idea, right? So with that, that's what's happening here is that this has been put in one to one. What's the word? Respectively, right? So it's been respectively put in there. You basically just put in this, and then because it's respective, this was Q, so this goes here, right? And this was R, so this goes where R went. It's all about respective, right? Does that make sense? So that's how the dangling implication substitution works. Now, what's weird about this one? Okay, this is where, what the heck? Get that out of there. Now, what's weird about this? What needs to be explained about this? So, we're doing the dangling implication substitution here. But what needs to be understood is that we also have this. The 3 star 3.14, not P over Q. Now you may go like, okay, wait a minute. How does that then result in P and not P, right? Because if you look over here, this is Q. How does Q turn into not P, turn into pretty sure it's, yeah. Okay, let me explain that a bit. How does that, rather, how does Q turning into not P relate to a implication of not P or not P? And if you're asking that question, like, how does this have, how does, like, let me rephrase, let me reassemble this. The question here that I'm kind of answering is, uh, what does this have to do with this? Right, like, why not leave out the implication altogether? Okay, so here's where things get really wacky. Now, as I try to explain here, but I'm going to explain in extended detail verbally. So let's take all of our constituent parts and run them down here. So if you remember, the implication has to do with the consequent, right? And what we're getting, or rather the antecedent, and what we're getting is a change in the consequent. Now, if you view the whole thing like this, hold on, let me make that a different color so it's a little more obvious. So if you view it as not, I want a color that's easy to see. If you view it as this, well, I probably should have done that in size 24, yeah. Don't worry, I'll redo that. Here we go. Now, the relationship is still the same. Between the blanks. Now, if you're wondering what I mean by that, it's pretty simple. It means that since this is still 3.14, it's still to color code it. I guess I'll go with red. Okay? So they're still linked that way. And what I mean is like not P and P are connected. Not Q and Q are connected. So since the relationship between the slots is the same, and really the relationship between the two halves of a sort of what not P and not P are would be the same anyway, we get right not P or not P. Right? And I know this is kind of wild, but just hear me out here. P or not P. Right? And the thing is, what we're looking at here is inversion. So what's really going on is, so if we compare those, right, we compare the original what's remaining intact is the morphology. The shape relation between the implication, the reference, and the referenced theorem. So not P is inverted to P, not Q is inverted to Q. Therefore, in keeping with the original referenced theorem being used as a schema, the first and second slots are inverted respectively in the third and fourth, just like in the original. Okay? So, what is actually happening is that the reference itself is being justified by the implication. If that makes sense? I just wanted to explain that because this is something that is very, like the implication, the Dangling Implication Substitution method is very... I like the way that they do it that isn't this. Like, I like the simpler way that's seen in 322. You know, like right before it, 322, where it's the simpler connective into the reference. I dislike intensely the implication, only because it is so... I'll put it this way. I dislike it intensely for having to explain and infer. I like it astonishingly. I think it's incredible how it's done in elegance. It is an incredibly elegant, incredibly like high like it's such a... It's like if somebody made a Fabergé egg out of, I don't know, sand. It's incredible. It's and I know that's a bit of an I know that's a bit hyperbolic, but to me it is seriously incredible. Like the how they did that. That is incredible notation and, you know, technique, but trying to explain it and trying to like hold it in your head is such a pain. And as elegant and as awesome as it is, it does take some explanation. And I figured that I'd make a that's me patting my book. Good book. You've done well, book. But that's me sort of going out on a limb and making a video expressly about this theorem and the implication substitution method, just to make it clear what's going on for anybody who may be going through these graphs and sees that and it's like, what the heck? And then they read Principia Mathematica and they're like, oh man, what even is going on here? Right? So this will be maybe not even so special an episode. This might be what the series mainly turns into, is me explaining stuff like this from the book. I will still do regular graphing episodes, but this and the next one for 326 will be definitely particular episodes where I highlight a theorem and what's going on in it and just kind of go over it and explain it. Because I really think it's I think it's kind of a cool idea for me to do these, but also I think it's just really gnarly, some of the stuff that is done in Principia notation-wise, that it might actually necessitate like a video assist. Right? I mean, I give an explanation down here, and I hope that for people who don't find my YouTube channel, who are interested in Principia, that they can just get it from the graph. But in case you can't, in case you don't, or in case you just find this stuff interesting and wanted to watch a video about something in Principia Mathematica, there you go. Anyway, and yeah, for whatever reason, this is your first time watching one of my videos, this little guy's like one of my mascots. I like having a little mascot in the corner whenever I'm doing stuff. Helps keep me optimistic. It's like scenery. It's almost like, if you imagine these meta charts as my office, this is like a little hang in there poster in the corner of the office. But anyway, that's this. This is that. Thanks for watching. And the next episode of this, like I said, will be just 326 in the same line as this one was. I don't know whenever I'm going to be graphing, doing a long form graphing video again. But I will say this before I go, that the third chapter is incredibly short. It's just under 4 pages. And chapter 4 is long-ish. Yeah, it's about as long, I think. In number, it's about as long as chapter 2 of theorems. I'm not sure I would say it's as long in content necessarily. It's got some monsters, though, for the demonstrations. Anyway, that's it.